Here's your pre-calc lecture for 11.1.4, and it's pretty long. It has converting between polar and rectangular forms. So I'm going to put a separate YouTube video from a different teacher that shows you how to do polar to rectangular. And then that same YouTube guy, he's going to teach you rectangular to polar. And I'm going to show you a little bit about 11.5.8 and 5.9. So 11.5.8 says the graph of the equation r equals 5 over 9 cosine theta plus 7 sine theta is a line. So I want you guys to feel free to put these into Desmos. You have to type in r and you have to use theta or else it won't know that it's polar. But you can graph that. Explain why the equation can be written as 9 times r cosine theta plus 7 times r sine theta equals 5. So if you know how I love to do cross products? If I did cross products, wouldn't I get this r times this denominator equals this 5? Okay, so that's where that comes from, just from cross products like this. Right, you distribute the r. Okay, and then on letter B it says, show that the rectangular form of the original equation is y equals 9/7 x plus 5/7. So in the other videos that I hope you watched them first, the YouTube videos, he tells you that y equals r sine theta, and he shows you y and everything, and x equals r cosine theta. And it should make sense that if this is r and this is x and y, Pythagorean theorem says x squared plus y squared equals r squared. So these are some little formulas that you need. So if I plug in 9 times r cosine theta, well, what's r cosine theta? R cosine theta is x. So that would be 9 times x. And then 7 times r sine theta is y. And that's equal to 5. And then if I just go ahead and solve this for y by subtracting 9x on both sides and dividing everything by 7, then it's just a little bit of algebra that you can use. So you're using these 3 facts here to when you're converting back and forth from polar to rectangular or rectangular to polar. So now we're on 11-5.9. It says, using your results from the previous problem, rewrite each of the following equations in polar form. So you just plug in these, just do like a substitution. So like on this one, since it says y, I know that y is equal to r sine theta, and this x is equal to r cosine theta. And then you can just do a little bit of algebra to it. So bring that over to the other side and solve it for r, and you get that. And then for letter B, sometimes you want to, actually for letter B, it was y equals x squared. So for y, you're going to fill in r sine theta. And for x squared, you're going to fill in r squared cosine squared theta. And then to solve it for r, just divide both sides by r, and you'll get this. So just doing a little bit of algebra. On this one, x squared plus y squared. Well, x squared plus y squared is r squared, and x is r cosine theta. So we're just taking these and doing substitution, and then doing a little bit of algebra, trying to solve for r. So I hope that makes sense. So that was 11.5.9. Try to make it through this in 10 minutes if I can. Here's 11.6. 60. Now rewrite each of the following equations. In rectangular form, write your equations in a useful form, not necessarily y equals form. So they give you a hint to multiply both sides by r, because we know r sine theta is y and r cosine theta is x. So if these had r's on them, we'd be able to swap in a y and an x. And then that gives you r squared over here. I think I did all this. Yeah, r squared. So r squared over here is, we know that r squared is x squared plus y squared. We know r sine theta is equal to y. We know r cosine theta is equal to x. So you can just leave it like that. Just a little bit of practice on if you have something in rectangular and you want to put it in polar, or if you have something in polar, well, these ones you have something in polar and you want to put it in rectangular form. This one, letter B, it started out as r equals 3 times cosine of 2 theta. Well, cosine of 2 theta, that's not one of our formulas. Like, we know x equals r cosine theta, and we know that y equals sine r sine theta, and we know this one we can even solve it for r if we want to. But we don't have anything with a 2 theta, so we're going to have to use, sometimes we have to remember that there's a double angle formula somewhere. Well, it's right here, isn't it? Cosine 2 theta, or cosine 2a, is cosine squared a minus sine squared a. So that's what we end up having to do for the cosine 2a right here. And then we have cosine squared theta. So we need a r squared on each one of these so that we can swap them out for x squareds and y squareds. So if I need an r squared here and an r squared here, I have to multiply both sides by r squared, and that's why I got the r cubed there. And then that turned that into the x, and then we got the y here. And then I shouldn't have distributed that. I could have just left it like that. This one, I did it the long way. So I know that r squared equals x squared plus y squared, so I thought of r cubed as r squared times r. So this is the r squared part. But then I still wasn't all the way in rectangular. I need to get rid of the r, so I know r is equal to square root of x squared plus y squared. But then I realized I can just write this as x squared y squared to the 3/2. And so you end up with this, or you can leave the 3 factored out like I have it up there. But when there's a will, there's a way to get these things done. Okay, so this one, I'm just going to go and show what they did on this one. So this one, we know that r is equal to square root x squared plus y squared. So that's where that came from. And then if you split this fraction up, 6 over 2 gives us the 3, and 6 over 3 times cosine theta. Cosine theta is I'm going to get back to this one. I'm going to make a second video.